A great deal has been written on ChatGPT and its implications for semantics and knowledge graphs. However, it occurred to me that not many people had ever bothered to ask ChatGPT what it thought about these things. So, I asked it. The responses here are unedited. Could you describe yourself for the audience?
Certainly. I am ChatGPT, an AI language model created by OpenAI. I am based on the GPT-4 architecture and trained on a vast amount of text data to understand and generate human-like text. My primary function is to assist users by answering questions, providing suggestions, offering explanations, and engaging in conversations on various topics. As a text-based AI, I can comprehend and generate text in multiple languages and cover a wide range of subjects. However, my knowledge is limited to the data I was trained on, which has a cutoff in September 2021. This means that I may not have the most up-to-date information on certain topics or be aware of recent developments. While I strive to provide accurate and useful information, I am not infallible, and my responses might not always be perfect. I am constantly learning and evolving to better assist users with their questions and needs. If you have any questions or require assistance, please feel free to ask.
What role do you see ChatGPT and similar systems having in the field of knowledge management?
AI language models have significant potential in the field of knowledge management, as they can assist in various aspects of organizing, retrieving, and sharing knowledge. Here are some roles that these systems can play. Information retrieval. ChatGPT can help users quickly search and retrieve relevant information from vast amounts of textual data, streamlining the process of finding answers to questions or locating pertinent documents. Document summarization. AI language models can generate concise summaries of lengthy documents, making it easier for users to grasp the key points and digest large amounts of information. Automatic tagging and categorization. ChatGPT and similar systems can help automatically tag and categorize documents, articles, or other text-based resources, which can facilitate better organization and faster retrieval of knowledge. Knowledge extraction. AI models can extract structured information from unstructured text, such as relationships between entities or key facts, which can be used to populate knowledge graphs or databases. Text generation and editing. AI language models can assist in generating, editing, or proofreading content, which can be useful for creating documentation, reports, or other knowledge resources. Expert system and decision support. ChatGPT can be integrated into expert systems and decision support tools to provide users with relevant information and recommendations based on their queries or specific problems. Collaborative knowledge creation. AI language models can facilitate collaboration by suggesting ideas, helping to draft content, or providing feedback during the knowledge creation process. There are many other potential areas as well, from training and onboarding to trend analysis, and of course, conversational interfaces. As AI language models like ChatGPT continue to improve, their role in knowledge management will likely become even more significant, driving innovation and enabling organizations to more effectively manage and leverage their knowledge assets.
Can you compare large language models with semantic graphs?
Large language models are AI models, typically based on neural networks, that learn and generate human-like text by being trained on vast amounts of text data. They excel at natural language understanding, generation, and various NLP tasks, but their knowledge is implicit and context-dependent. Semantic graphs, also known as knowledge graphs, are structured representations of knowledge that consist of entities and relationships between them. They provide explicit, easily queryable knowledge, allowing for efficient reasoning and information retrieval but lack the ability to process and understand natural language. In summary, large language models excel at processing and generating natural language, while semantic graphs are designed for structured knowledge representation and reasoning. Both approaches can complement each other to enhance the capabilities of knowledge-based systems.
How can knowledge graph systems be improved to be better compatible with large language models?
To improve knowledge graph systems for better compatibility with large language models, consider these strategies: convert structured data into natural language, transform knowledge graph triples into text to facilitate integration during pre-training or fine-tuning of language models. Improve entity linking and disambiguation. Enhance techniques for identifying and linking entities in text to their corresponding nodes in the knowledge graph. Design APIs for natural language queries. Develop APIs that allow large language models to query knowledge graphs using natural language, enabling seamless access to structured information. Knowledge graph guided generation. By combining the generation capabilities of large language models with the structured information in knowledge graphs, more accurate and relevant text can be generated. For instance, when generating a summary or a description of an entity, the model can prioritize information from the knowledge graph to ensure factual correctness. Hybrid models. Developing hybrid models that incorporate both graph-based and neural network-based components can leverage the strengths of both approaches. For example, graph neural networks can be used to learn latent representations of graph-structured data, which can then be integrated with large language models for natural language processing tasks. By implementing these strategies, knowledge graph systems can better interact with large language models, improving their performance and capabilities in various knowledge-based tasks.
How can large language models be improved to be better compatible with knowledge graphs?
To improve large language models for better compatibility with knowledge graphs, consider these strategies: incorporate structured data during pre-training. Integrate knowledge graph information into the pre-training phase by converting triples into natural language sentences or generating synthetic text. Design graph-aware architectures. Modify the language model's architecture to process structured information from knowledge graphs more effectively, such as by integrating graph neural networks or other graph-based layers. Fine-tune with graph-based tasks. Train the language model on tasks involving reasoning with knowledge graphs, such as predicting missing relationships or entities, link prediction, and entity resolution. By implementing these strategies, large language models can better leverage structured knowledge from knowledge graphs, improving their performance on various knowledge-based tasks.
You mentioned GNN several times here. What's a GNN, and how does it factor into knowledge engineering?
A graph neural network is a type of neural network designed to process and learn from graph-structured data. GNNs work by iteratively propagating and aggregating information from neighboring nodes and edges, allowing the model to capture complex relationships and dependencies within the graph. In knowledge engineering, GNNs play a significant role in integrating knowledge graphs with machine learning. GNNs can learn from structured graph data, enabling the integration of knowledge graphs with machine learning models for better understanding and reasoning. Graph-based machine learning tasks. GNNs can be used for tasks like node classification, link prediction, and community detection, leveraging the structured information in knowledge graphs for improved performance. By utilizing GNNs in knowledge engineering, organizations can better process and analyze structured graph data, enhancing the capabilities of knowledge-based systems and applications.
What do you see as the future of knowledge graphs and large language models, say in 5, 10, and 25 years' time?
In the future of knowledge graphs and large language models, in 5 years, better integration between knowledge graphs and language models, and advances in graph neural networks for improved graph-based learning. In 10 years, hybrid models combining strengths of both large language models and knowledge graphs, along with personalized knowledge graphs for tailored and context-aware information. In 25 years, potential contributions to artificial general intelligence, unified knowledge representation frameworks combining benefits of language models and knowledge graphs. These predictions are speculative and based on current trends. Actual developments may diverge significantly from these projections.
Thank you for taking the time to be interviewed.
You're welcome. I'm here to help and provide information whenever needed. If you have any more questions or need assistance in the future, don't hesitate to ask. Have a great day.